Testing. Testing. I think we're live. I'll wait a minute before we really get going here. Today is going to be probably kind of a quick demo. It's not really like a full-on workshop like you've probably seen me do before, but I wanted to show a quick kind of demo of serving in Union, which is what this session or talk was about if you RCP'd on Eventbrite. And I'm going to send some links in the chat. Let me get a little situated here as people are joining in. Also, as you're joining, say hello in the chat, maybe where you're watching from, and maybe a little bit about why you're interested in serving models or applications, or really what you're building, I guess is maybe a better question. It's a little bit about what you're building, what you're learning right now. Say hello in the chat. So I shared a link to the docs. I'm going to post these in a couple places here, so give me a minute. Say hello in the chat. Got some echo going on here. All right, share links to the docs. If you do want to follow along, I'm going to show a quick example of maybe building 3 different types of applications. There's obviously way more different types you could build. Union serving is really flexible. You can serve any type of model or application. We're going to look at kind of 3 little intro to serving with Gradio applications. You could also do things like using fast API, hosting models at endpoints with that. We won't look at that today, but you'll kind of see the structure of how you would do that. You would just change like one file to have your API endpoints versus a Gradio application. And if we have time, I can also kind of show or talk a little bit about like this is a training a model workflow for an LLM, and then we serve this model. So I might bring that up as another example with a Streamlit application. So just to kind of show what we're going to go over, and I'll show the code, how to create all these 3 different applications. And then again, maybe we'll go into the other one, like I mentioned. We'll do kind of a first, like a Hello World Gradio app. So Gradio is an application, or sorry, a library that is now run by Hugging Face. It was a different company, but they acquired them a couple years ago, and it allows you to build really simple interfaces or build interfaces simply with Python. So it has a lot of pre-built little building blocks, but it's also fairly flexible. But it's great for building like demo applications or something that you need a quick kind of UI for. So really popular in the machine learning world of building like or training a model, deploying it, and then having a Gradio interface interacts with it. So first we'll build a little Hello World app. This is just going to show how we define the application to serve, and then how we can bring in a Gradio app. So this just has a little input and a slider here. We submit, and it's going to add, oops, let me refresh this. It might have spun down, and that's probably what happened. So we'll also talk about scaling, and that's probably exactly what happened here. Is these probably spun down because I had them up, and I have the min replica set to 0. So when no one's using them, it'll spin all the way down to save resources. So let's try that again. Hello. And then now we get an output with hello, and then a whole bunch of exclamation points that is from the slider. The next app that will kind of show how to build, this is going to be using a Qwen 3 model. So actually show how to download the model. We're going to host that in Union for artifacts, and then we'll be able to interact with it. So I haven't tried this. What is Flyte, the open source software? And you'll see that it's going to have a thinking stage, and we're actually going to stream all those tokens as it's doing that reasoning thinking stage. And then we'll also stream out and get the answer here. So we're going to show how to kind of download this model, save it as a artifact in Union, and then serve it here in an application. And then finally, we can look at using a VLM. This is small VLM from Hugging Face, so it's really, really small. It doesn't always do perfect, but we'll look at how to use this to get insights on what's going on with an image. So we can actually access a webcam. I'm not sure if this works when streaming on it, so I haven't actually tried this yet. Let's take a book and see if it can understand what's going on in the book. Again, this isn't always perfect because it's such a small model, but let's see what happens here. Now we can try a different book. I've had variations of success with depending on like the background and stuff like that of what's happening. there. So it says, man in the photo has a beard and is holding a book called AI Intelligent. Not quite, pretty close though. Again, this is a very lightweight VLM, but this is kind of an example of how we can serve these different applications. So we're going to go through, see what those 3 applications look like. First, I'll also share out. Actually, if you do want to follow along, these are the repos. I'm not going to go through and run this exactly like a workshop where I wait for to make sure everyone is in the right spot. But if you do want to follow along and build these applications, there's a GitHub repo here. And you can actually go to this Open in Colab button. This will open up a tutorial notebook. And you could run all the code cells in here. And this will walk you through how to basically serve those 3 different types of applications that we just saw. So I'm going to share that in LinkedIn as well. So if you do want to follow along and build the things that you're going to see today, you can do that here. Just a little bit about Union as well. You should go to check out Union.ai. So we're a workflow and inference platform. Make it really easy for you as an AI engineer or data scientist to build complex pipelines and serve models like we're going to see today very easily, all in a Python SDK. So you don't have any bottleneck really of going through a lot of different areas for configuration. We can host on your cloud. Most people use this in their own cloud, like on AWS EKS cluster, for example, but we also run really in any cloud that you could put a Kubernetes cluster, and then also on-prem options as well. So if you want to build out a complex training pipeline with a lot of features like caching, a lot of efficiency features that end up usually saving a lot of money and a lot of time, check out Union. And then also we're going to see mainly the serving aspect today. So if you also want to serve applications like you're going to see in your cloud with the interface and stuff that we have here, you can book a call. Or if you want to try out what we're seeing today, I'm actually using something called Union Serverless, which you can sign up for free. If you go to the site and go to the login button and then hit sign up. Actually, I guess I can also post this link for people. I need to open this in incognito so it doesn't route me. You can sign up for free. There's no card required or anything like that. And you get $30 of cloud credit. So if you want to, again, run the applications that we're going to show today, you can sign up for free. No card required. Should just take a minute to sign up. And then you can go through that Colab notebook that I shared earlier as well. All right, so let's go through this first one. And instead of me running through the Colab, I'm going to show my code locally here. And in that repo, there's 3 folders. This 0 simple app, and then LM chat, and then the CV images. This is the VLM one. I should probably rename the folder there. So let's first look at this simple application. This is how we're going to serve the app that we saw here. And if we go into the Union dashboard, if you do already have an account, you can look at this apps tab. This shows all of our active apps or apps that are active but spun down. So you can see this 0 out of 1. We'll talk about this later, or actually just in a minute, how we define this. So we define an application. This is how we define how it scales, what container image it should run in, and everything like that. We're doing this in an app.py. Again, you could name this whatever you wanted, but app.py is probably a pretty good convention. We're importing some libraries here. We'll just talk about them as we use them. But the big ones probably is from this that maybe you haven't seen before, even if you've used Union, is from Union app. We're importing app and then some scaling metrics. And then I'll show this where this container image comes from in a second after we talk about defining the app here. So creating our first hello world simple app, we're just going to say gradio app is equal to app. That's the part we imported here. Give it a name. In this case, just gradio app. We are defining what environment it should run in. And so I'll show this right after I go through this file where this comes from, because we actually are going to use something called image spec, which is built into Flyte and Union. I didn't mention Flyte earlier. Flyte, Flyte, is a really popular open source that a lot of people use to do AI orchestration for their pipelines. And you can use image spec in there as well. Again, we'll talk about that in a second. Then we're defining the port where we want our app to run on. If we want to include any other files, so this main.py includes our Gradio app in this case, but this could be your Fast API or Flask or what other type of code you want or endpoint libraries you want to use. And then we have arguments to launch our app. So in this case, we're just saying Python main.py. And then we have these limits. This is requesting the amount of resources that we want for this application to run on. So in this case, for our simple hello world, we're just saying we want 2 CPUs and 8 gigabytes of memory. And it's going to be allocated to that. Or sorry, the request does that. The limits is what you can set. If you do request, this is kind of a soft limit. This is what you're going to try to request from the scheduler. Then you could add limits. It's a hard limit, so it won't go above what you set here. And then we have min replicas. So this is how you decide how your app scales down. So in this case, we have a metric down here that we manually set to 5 minutes. I think the default is also 5 minutes, but you could set this to 2. You could set this to much higher. And basically, when no one's using your application for 5 minutes, it's going to scale down to whatever this min replica is set to. And we have it set to 0. So that means when no one is using our site or our app here for 5 minutes, it's going to go to 0. We're not going to be paying for any of those resources. Then when someone visits our site, it's going to have to spend a little bit of time to spin up the site again. And then it's going to go to the max replica, which is just 1 in this case. But we could set this to much higher. And we have the scaling metric, meaning when we set it to 2 here, basically when more than 2 people start coming in to visit your application, then it's going to create another replica with these resources. So this is a really easy way directly in the Python SDK of, let me zoom in, sorry about that, of just defining how you want your app to serve, but also scale. And when you want it to spin down, how much concurrent users do you want to have before you spin up other replicas? All just kind of a few lines of code here that make it really easy to serve the application. We'll look at containers.py next, and then we'll go to main.py, which is the Gradio app. So containers.py, this is where I just define image spec. You could do it directly in that file too. It's not very big here. It's just a couple lines of code. I have it separated so I can just easily import it into all of the different apps here. But you could have, for example, this simple app doesn't need transformers library or PyTorch or anything like that, which is in the requirements.txt. But I just made it easier for people to run this. But you could have different containers built for different type of applications here. In this case, I'm just looking at the requirements.txt, and when it starts to launch this app, it's going to look and see, does that image exist? Yes or no? If no, then it's going to go ahead and build it. So if you are following along in the notebook and you run that code cell for the first time, it's going to take 4 minutes or something to go build the container image, like a Docker file, based on the requirements that we passed it. And then it can serve the application using that Docker image. And we're also passing in this case, CUDA 11.8, but you could pass in different versions here if you're running on specific CUDA versions. There's a whole bunch of other parameters you can pass in, like if you want to include other apt-get files, not just like a requirements.txt or a Python package. So if you want to include a C++ builder, for example, if you're doing like quantization, you'll need to do that. You can just include this directly in your Python code here as well, and it's going to build the image. So then let's go look at our main.py. Again, this is still under just the simple app here. And then this is a really simple Gradio app, basically taken from like their Hello World documentation. We have a function here called greet, which is going to take in a name and a intensity number. Again, that's going to add in the exclamation point. And then we're going to launch the interface, which we're just calling demo here. It's going to, again, take in, or it's going to use that function, and it's going to take in the input here, the text and slider, and then output text. And then by default, it's going to launch on this server 000 on port 88, which is what we had defined in the app.py. So then if you want to run this, you just run union deploy apps and then pass the path of where that app.py, the other file that we looked at over here, lives, and then the name of the app that you defined here. So in this case, we say Gradio app. And then when you run that, you get this little Gradio app that we looked at. If I go into the interface here in my apps tab, I can see, again, it says it's active. I can click in on it. I get an overview of deployment logs. I also get actual logs. So if you want to debug and see what's going on here, this is really helpful. And now that it's deployed, I can click on this endpoint here. Oops. I clicked into the Gradio chat, not the Gradio app. Click into this. Again, it spun down because we weren't using it for 5 minutes. So now it has to spin back up. So that was really fast though. So it had that scaling metric. Probably if we even looked at the logs, it had to scale up again. So again, we can say, I'll say Union. And then it says hello Union. So that's like a really simple example of serving an application. So now let's take a quick look at the Quinn 3 chatbot. We exit out of the other one. Again, let me type something in here. What is a what's a good thing to ask? Elephant. And it's fun if you ask it harder questions, you'll see it kind of doing more and more reasoning, really simple ones. It'll keep the reasoning tokens very light there. But you see it did the thinking stage that was streamed out. And then we get the actual answer here. So let's look and see what this looks like. So this gets a little more complex. We're also hosting a model, not just a Gradio application. So to download the model, there's different ways of doing this. You could always download directly from Hugging Face every time it scales up. You can also, if you look at the docs, there's a kind of a quick way of when you're deploying an app to pass in a Hugging Face string, and it could download the model. In this case, I went ahead and created a task. So if you've used Union or Flyte before, you might be familiar with this. This is what most people know us for right now, is kind of our SDK and platform around building out those training pipelines, like I mentioned, or really any type of pipeline, but a lot of people use it for AI training. You basically define a function. In this case, it's just going to be download a model. And then we have this decorator that we add to the function. We pass in a container image, just like we did before. So this is actually, again, pulling from the same container. And then we're enabling caching. So this would be if I was going to if I was going to use this task in a pipeline, like for training a model. Today, we're just downloading it. Caching means that every time I run that workflow, by default, it's not going to rerun this task. So it's really useful to, again, save a lot of time. Like if it has to download this model every time we're doing hyperparameter tuning or something in the workflow, this can save quite a bit of time. You can give it a cache version as well. So you can have this logged for different versions to roll back to if you wanted to. And then we're requesting the exact resources that we need. In this case, we're not using a GPU. We just need CPU and some memory to, again, just download a data set. Then we have our Python function. By default, we're going to pass in this name. It's going to be the Quinn 3 600 million parameter model. You could update this to be a different one. Just if you do update this to be a bigger one, there are some areas when you request resources in the app that you might need to up them. And then we're going to return this as a Union artifact. And we'll talk about this in a second, what that looks like. But basically, it allows us to store it somewhere and then very easily query it down and pass it between other workflows or teammates. Then we're just saving it in the local directory here. By default, everything in Flyte or Union is kind of a containerized task. So you need to think about how do you pass information out of those containers when they spin back down? Because again, you're spinning up this compute to use it for something and then it goes away. So if you're not used to developing on containers, it can seem a little tricky at first. In Flyte and Union, we have Flyte directory and Flyte file, as well as just kind of automatically serializing any data that we pass outside of a task. And this makes it really easy to pass things out of a task or save it as a Flyte directory or Flyte file. That just means that when that container spins down, you can get a URI where that lives, like on your blob storage, and then access that information between other containers, or in this case, it's going to be an artifact that we can just download kind of anywhere. We're just passing in, we're using auto model for a causal LLM. If you were using like classification, you would change this out like a BERT model. You could change this out for auto model for sequence classification, pass in that model name. And then this is going to download, and we're going to save the model and tokenizer. And then we're returning that as an artifact. And if I go to my Union tab, my Union UI here, if I go to this artifact tab now and go to, let's see, I have quite a few artifacts in here. There's my Quinn 3 model. I can click in on this. And again, every time you run this, like everything is versioned. All the workflows are versioned. All the artifacts are versioned. So you can always come back and like reference specific versions if you want to. By default, we can also just call a .query on this artifact and bring in the most recent version. So if I click on this kind of lineage tab, I can click overview, and this shows me the workflow exactly where it came from. In this case, the workflow is very simple. It's just downloading a data set, but we can click in and get any information like inputs and outputs. Again, all these are versioned as well. Now that we downloaded our model, when you would run, again, this is in the tutorial notebook, but you just call it union run remote. We can also run locally here. In this case, we're running remote. That means it's going to run off into, in this case, the Union Serverless cloud. But again, it would be set up in your cloud if you're using like Union Enterprise or Flyte. And then we just pass it that model.py file and then call that function download model. This is actually just creating a single or running the single task remotely here. But pretty often you would have multiple tasks like this in a data pipeline or in a training pipeline, and then you could call it as a workflow, and a workflow defines how data and tasks are kind of run together. So if I go to the app.py, this is very similar to kind of like we did before for the simple app, except for now we're defining an artifact above. This is our Quinn3 model. And then we are giving it a name like before, but now we're also passing in inputs. So we're just going to call this downloaded model. You could give this any name you want, like Quinn3 model. And then the value for this, we're using this Quinn model .query. So like I mentioned, the .query is going to automatically bring down the latest version of the artifact, but you could pass in a specific hash value here to get any specific version if you wanted as well. And then download equal to true. Every time this spins up, it's going to download that model and then kind of cache it in there. So again, we have container image, port, including the main.py, which we'll look at here in a second. That's our Gradio app and how we interact with the model in this case. But this, again, could be like your fast API code or Flask app. The Python arguments to start it, the limits and requests, the resources. In this case, we are adding more memory and a GPU here. By default in serverless, the GPU is an L4, but you can also explicitly define that here. And in serverless, again, it would depend on your cluster if you had this deployed in your cloud or on-prem. But in the serverless, you can also use A100. So we have L4s and A100s that you could request here. And then again, our min replica is 0, so it's going to spin down. We're not using it. Max replica is 1. And then we have our scaling metrics and concurrency like we talked about before. Something I forgot to mention before, I think was there, is by default, the URL to access your application is going to require your Union authentication. But you can also comment this out, or sorry, uncomment this, and then it would say requires auth equal false, and then your URL could be publicly accessed. So by default, you have to authenticate to use it. You can add this in to make it public. And then if we ran deploy app, it would start the app, but I forgot. Let's look at main.py real quick. We're importing Gradio, get input, some stuff from transformers. If you've done LMs before with open source, you've likely used the transformers library. We're getting the path for our downloaded model that we defined earlier, getting our tokenizer and our model from that downloaded model, setting it to eval so we can just use it for predictions. Then we have our chat function, which is a little bit bigger or more complex than our simple one. We have messages, which is, we have the role of user and content. Again, you've probably seen this for using LMs before. Then we have our prompt, which is going to be tokenized and then passed into the LM. And same with our inputs. And then this is a cool thing built in to the Hugging Face Transformer library called Text Iterator Streamer. So when we interact with this, let me go back to this again. Let's see if it's still spun up. I should increase the scale down time for the live workshops sometimes, I think. What does that be? So here we're getting these tokens out kind of in this cool live format that you might be used to, like if you use ChatGPT, etc. By default, if you just call in an LM and you pass in like an input and then you get a response back, you're going to have like some waiting time and not get this kind of streaming tokens. So there's a really cool built-in function inside of Transformers library that allows you to basically just stream the inputs, or sorry, stream the outputs as you're getting them. And you can skip the prompt and also automatically skip special tokens. So usually there's special tokens like in Quinn3 about like think, etc. We're going to skip those and just output the actual text there. This we pass in the the settings that we want and inputs for the Quinn 3 model in this case, like the max amount of new tokens it can generate. So you could increase this if you want longer responses. If they seem too short to you, you can change the temperature if you want it to be, more creative, less creative, etc. And then it's going to use this token as kind of the stopping point of the stream. And then we're going to pin that kind of thinking face and the answer, or the brain for the answer. Like you saw, this says answer here. And when it was thinking, it had the thinking face. Oops, I think again, when you get this error on a Grady app, usually that means it spun down. And I think I had a different tab open maybe. Like I mentioned, I think, let me see. Probably spun down. Or could be some weird Grady bug. If this errors again, let me come back to this in a second. Nope, looks like it's going, I think. Yeah. So you saw, well, you didn't really see the thinking token. So sometimes when it's a simple question, it'll think too fast or not stream any outputs, and then you'll just get the answer. Ask a more complex thing like, what is the best vitamin for humans? And then it'll usually start have more of a thinking phase for something like this. So it's like, oh, there's a lot of vitamins and different stuff. I better think about this before I stream give an answer. So you can see it's doing way more thinking. And then we have our Gradio interface just like we did before, passing in that chat function, giving it a title, giving it a text box that we can enter in with some placeholder text. And then it's not multimodal in this case, so they have an ability to easily make the chat interface. So we get this kind of chat interface pre-built inside Gradio, which is great. Again, really good for building these quick applications. And you can have it multimodal. I think if you hit true, then it'll have an ability to upload images, basically. Which actually, I think Quinn 3 model, maybe not the 6 million parameter, but the other big ones are multimodal. So you could enable that and then have it be able to upload a image. And then again, we're just kind of launching the application, the Grady app like before. So that's how we built this one. And then we can go in real quick. I can show, I know chat's been kind of quiet. So if you have any questions, let me know. Otherwise, I'll just show this kind of VLM one, which again, let me get that spun up if it's not already spun up still. Yeah, so spun down. Again, it will take a minute to basically load in that model. You can see it's scaling back up from 0 to 1 replicas. But again, when it's spun all the way down, we aren't paying for those compute resources. You can even see the GPU usage that we have listed here as well. And let me see it. Let's try a different book and see how the VLM does on it. Does anyone think this is interesting? You want to build some sort of radio application or application with what you've seen so far? Makes it really, really easy to define the scaling metrics, which is really nice. So with this kind of image input, by default, you can it's going to allow you to upload an image, which can work great. You could try it out. You can copy an image in from your clipboard if you had one. And then there's this little webcam icon. So I'm going to click that. And then you have to click access webcam. Again, let me hold up a book and see if it gets any of the text in here. And then you hit this little photo icon. And then took a photo of it. And then we'll hit submit. And let's see what happens. This is a pretty small VLM. It's kind of unpredictable how well it'll work. It says a person holding a book in front of their face. The book is titled Elements of Programming for Interviews. That's That's actually, yeah, that's Elements of Programming for Interviews with C++. Yeah, that's actually got the text right this time. The cover of the book is white and with blue and black text. The book is being held by a person with curly hair. You can even, I guess it sees my hair enough. The person is wearing a black shirt. The person is sitting in front of a purple wall. I do have the purple light behind me, so it definitely looks like that. There's a microphone in front of the person. There's a shelf on the wall behind the person. The shelf is filled with books. The books are different. And then again, I think you could increase max token size. It looks like it wasn't quite done. Saying something there. Someone asked a question: does Union do text to speech? So Union basically provides the infrastructure to do any compute that you want. So if you want to do like a Gradio app like this and serve it with kind of how we've been seeing you define these apps here, you can definitely do that with text to speech. We don't have it's like bring your own models, bring your own data. And again, like I mentioned, a lot of people use this for building their AI pipelines to train their own models, and then you could easily deploy those models exactly how we're seeing it today. What's your text to speech application that you're trying to build? All right, so I'll quickly go through this. Doesn't really have anything new in this one that we haven't already seen. We're just calling in this artifact from model.py. We download a model just like we did before, but instead of the auto causal LM, this is auto model for vision to sequence or to sequence. So this is the type for this small VLM, which is Hugging Faces. Again, like this is a really, I forget the amount of parameters, but it's a really small VLM. That's why it's not as good as some of the other bigger ones. If you run this downloads the model. So again, you could follow the tutorial in the notebook if you want to follow along. And then we're passing that in as an input here. Container image, just like before, the port we want to run on. Again, this is all stuff we saw in the last one. If we go to the main.py, this is our Gradio app for the VLM. So again, we're trying to load in that downloaded model. And then we have this VLM inference. We give it a little prompt saying what's going on in this photo. Again, you could adjust this prompt way more to maybe get better outputs from it. And then we get the predictions back with the generated text from the VLM. And then we just, again, are setting our Gradio interface with the VLM inference function. We set this to gradio.image instead of the chat interface. Saying upload or take a photo, and then we get our outputs in text, and then again, just adding titles and descriptions here. So really, really simple to create the application with this whole kind of UI, but having access to the model, which is really cool. So that something that talks like a Furby or Kermit the Frog, but with an English accent. That sounds like a fun project. I have wanted to kind of get an old Furby if I see one somewhere, and redo like the kind of AI or whatever inside of it, because I think it'd be kind of fun. You should be able to drive the motors and still make the Furby run, but then you could use your own like Raspberry Pi or something like that to do the processing. I think that'd be really fun. I don't know if you have a hardware part of your project, but I've been thinking about doing something like that for a while. I think that would be really, really fun. So that was like kind of a quick demo of seeing serving in action. Again, mostly it's in these app.pys if you want to see kind of the cool Union part. And this doesn't have comments here. You can see it looks cleaner. It's not that many lines of code, and this really allows you to have access to the infrastructure that you need to deploy your AI models on, with all the scaling metrics and stuff really easy to define directly in your Python code. Same with the compute resources. And since there's still people here, I can also show one more application. I can go show the SPERT sentiment analysis. Again, this will have to spin up, so it might take a minute there. While it's doing that, I'm going to show where this model came from. So instead of just downloading a model from Hugging Face in this case, this is my whole kind of training pipeline that I built. Again, this is all in Union as well. You can look at the code for this here. So if you actually want to learn or go through how to fully like fine tune a large language model, this is a good resource for it. It's going to build this pipeline that we're going to take a quick look at. So we have this whole pipeline where we download a data set, download a model, train the model, and then visualize the data. So we can actually see this is the data set that our model's trained on. In this case, it's a IMDb movie review data set. And we can log directly in those tasks, text or markdown or HTML reports. So you can have charts in here. You can have interactive charts like Plotly, kind of all logged here. I like this for seeing a lineage of like exactly what my data set looked like. So in this case, I log out the distribution. The charts aren't super interesting here because the distributions are the same because it's a clean data set from Hugging Face to kind of play around with. And then I log the first positive and negative review for the training, the validation, and the test data set. So I can always go kind of see what this might look like anytime I come back to see where my trained model came from, which is really nice. And then my model evaluation, I also have, if you click on these, you see there's this deck button, and I'll show in Python or in the code how you can make these in a second. We also have our model evaluation. So again, with lineage, I kind of have full lineage for like every part of the workflow, like where did the model get downloaded? Where did the data set get downloaded? Did anything happen to the data set, like pre-processing along the way? After the model was evaluated, what did that look like? I can just go easily grab kind of all the stuff here. What was I going to show next? Oh, so this, by the end of this workflow, and in the workflow, by the way, it shows how to do full fine tuning, LoRa fine tuning, so low rank adapters, and quantized LoRa. So if you have limited memory, you want to learn how to do those things, again, you can go check out that notebook. And I'll actually be doing a workshop on that in a few weeks as well. So if you actually want to run through, and I'll actually go through all the code line by line in that one, make sure everyone is following along. You can RCP for that. I can share out the link here in a bit for that too. But basically this workflow, after it trains the whole model, creates an artifact as well, which is this fine-tuned IMDb model. And you could add more information in like a card here, which I didn't in this case. But again, I can go see the lineage out of this workflow. These are all the artifacts that got created. So I also saved the data sets, the test, validation, and training data set. Okay, I can see this is where the fine-tuned model came from. And again, I can click into this. And this whole workflow is versioned again. So you get an entire snapshot of the data, the code, all the artifacts between all these different tasks. I could relaunch this, adjust some hyperparameters, and then have a whole new kind of snapshot of the pipeline. So really cool for seeing your whole lineage. Now that that model is trained, I am deploying it here. This time it's in a Streamlit application. And actually, let's go to Rotten Tomatoes and take a movie review. So this is trained on positive and negative movie reviews. Let's get this Karate Kid one. Oh, it's not out yet, so there's no user review. I like to grab something new usually and see what it says. Kind of fun. Is Lilo and Stitch out? Now playing in theaters. Okay, let's see some audience reviews. So let's start. This one is a 4-star, really long review. Let's grab this, throw it in our application here, analyze it. It's running and positive. Let's see if we can find a negative review. 2-star, so not the worst review, also kind of shorter than the data set that it was trained on. Let's pass this in and see how it does. And it did a good job of predicting that was a negative review. So we used our model that pipeline outputted. We pulled it in the same, kind of like we saw before. We can actually show what this looks like too. This is similar to all the other ones, but now we're just calling in that artifact, the fine-tune model IMDb model.query. And then if you want to look at all the pipeline code for this, again, I won't go through it all today, but that is all in here where we have our download data set, visualize the data, and again, we're using Union to define those tasks, and every single task there kind of becomes a node like you saw in the UI, and you define the compute that you want those nodes to run on. So you're not using like a GPU when you don't need to use a GPU is a really good example. You have every single task containerized and resource allocated. So for example, the training model uses more resources like a GPU. You can also view the resource utilization here, kind of in this graph, and then you could bring that down. So for example, I declared 12 gigabytes of memory, but we're really only using 1 because our task there is actually running on the GPU memory. So I could bring this 12 down to 1 or 2. And again, that wouldn't be a huge cost saving here, but it might be over time. Like if I'm rerunning this every hour or something like that, this is could be a big cost saver. Cool. So that was a super quick kind of intro of what serving looks like in Union. I thought hopefully you thought it was interesting. We'll be doing a lot more content on this soon as well. So keep an eye out if you want to see different types of applications. And actually, for anyone still here, what type of applications would you like to see examples of? I can tell you that some agent ones are coming for sure. So if you're building agents and curious how you can build reliable, scalable infrastructure easily for them, there's going to be a lot of content on that probably in the next several months that I'll be helping make some of. There's other people too that will be making it, of course, but I'm excited to work on it. I also like working a lot with computer vision stuff as well. So I have some plans for more of that type of content as well. And like you saw VLMs today, there's a lot of really cool stuff around, how can you use lighter weight object detection on the edge and then kick off sending a frame to a VLM from the edge when something happens, like if you're looking at a warehouse, like when a forklift drives in the area and then you want to measure for personal protection. You could do that by saying, "Oh, a person's here or a forklift is here now. Send this frame to a VLM." I thought there's a lot of cool stuff with combining kind of hybrid approaches with like edge and cloud hosted things. And Union would be really good for that or something like this, where you can have the scale down to 0, so you're not again paying for those resources for the VLM until you need to activate it. So again, when someone walks in there, or if you know the working time that people will be there, you could also have this on like a schedule and spin up. Cool. Well, if there's no other questions, I'll probably wrap up the live stream. Stay tuned for more projects, but hopefully you thought this was interesting and maybe really easy to build out kind of that scalable and resource conscious serving. Cool. I'll wrap up. If you have any questions, actually, I should get the Slack link for anyone who has questions later. You could join the Flyte Slack. It's pretty active. If you have any questions, ask them there. There's also an introduction spot if you want to introduce yourself, talk a little bit about what you're working on. It's really fun to kind of see what people are building in the community. All right, talk to you all later. Play around with these apps if you want as well. Again, you can sign up for the serverless and get $30 of compute credits for free and run these.